All right. So again, this video will be posted on my YouTube channel later. So that way you guys can reread it, or I mean, not read it, rewatch it if you had questions. But it's going to start from right now because I forgot to hit record. Okay. My notes will not be posted on Canvas. That was somebody's question in the chat. I showed you guys these notes just as an example. Like, I didn't even finish taking notes. I just kind of wanted to give you guys an example of, I mean, what mine would look like, okay? But these notes are all on Canvas, so you just kind of have to summarize them so that way they make sense to you, okay? All right. So next one is just more kind of definitions. Inductive reasoning. Okay, it's basically coming to a conclusion based off of observations that you make. Okay, and a lot of mathematicians and scientists use this a lot, like when they do the scientific method. So like one example of inductive reasoning, I could do it right now with all of you guys. So whenever I do like a Zoom meeting with my classes, I have, let me stop sharing my screen right now so I can look. Okay, I only have 3 people with their video cameras on, and like everybody else, they're just black screens to me, which is fine. Okay, but that it's like that, like in every single class. Oh, there's Kyle. All right, we got more. So basically, I could kind of make an assumption that all my classes, most of the kids are not going to have their video cameras on, because like when I Zoom with period 1, like nobody at all had their camera on this morning. And then period 2, there was like 2 people with their cameras on. So like I can kind of make an assumption that whenever I do a Zoom meeting, I'm not going to have a lot of video cameras on. So that is just an example of what inductive reasoning is. You kind of make a lot of observations and you kind of make up a kind of like an educated guess. You can call it that. Okay. So that is called, another way of saying inductive reasoning is just induction. It's just kind of like a synonym for that. Okay. All right, so scientific method, again, something you guys have used. I mean, you guys talk about this in science probably like almost every year. But again, the scientific method is an example of inductive reasoning. Okay, and we just talked about that. So you make a whole bunch of observations and then you make a prediction. Okay, but another word for prediction is conjecture. Okay, so these 2 words mean the same thing. So like if I were taking notes right now, I could say prediction equals conjecture. They're the same thing, because you guys all know what a prediction is, but maybe you haven't heard that word before. Okay. Another conjecture that I could make is that a lot of you guys probably have your phones sitting out right next to you right now. Would that be like a true statement? Again, you're not going to get in trouble.
Yeah, but like, you know, I don't really use it.
Yeah, I'm not trying to say you guys are like on your phone, but, oh, someone said they're using my phone to call. But I mean, when you guys, I mean, I know you're not supposed to have your phones out in class, but you're at home right now. I can't see you. Your video camera's off. So like, my assumption would be that a teenager would have their phone sitting right next to them. So that would be another example of a conjecture. Okay. Okay. And if you guys have questions, just stop me, okay? But a lot of this should be stuff that you have at least seen before, okay? So a counterexample is the next slide here. So does anybody actually know what a counterexample is? I'm gonna cover that up. Or maybe like, what about an example? What's an example? Are you guys scared to talk? Or can you guys hear me? Because last time I did a Zoom meeting, my kids like stopped hearing me after 20 minutes. Can you guys hear? Okay, you can hear. All right, good. So what is an example of something? Like, what does the word example mean?
It's hard to explain what an example is.
Okay, so
That's like the best way to explain what an example is to use an example.
well, okay, so how about this? Give me an example.
Of an example
Huh?
of an example of an example.
No, give me an example of a number that's divisible by 3.
9.
9. Give me another one. What other numbers are divisible by 3? Okay, Alex says 3,
15.
15, 6. I'm seeing pop up. Okay, so an example would be something that like proves that something's right or something that supports it. Okay, so what do you guys think a counterexample would be?
Something that doesn't work.
Something that doesn't work. Yeah, or something that proves that something else is wrong. Okay. So basically, that's what all this little paragraph says right here. If a special case is found that satisfies the conditions of the conjecture or the prediction, but it produces a different result. So basically meaning it's not true, that case would be called a counterexample. Okay. And then it only takes one of those to prove that something's false. So for example, if I made a statement right now or a conjecture that every single one of you guys has your phone next to you, I would just need to find one person who doesn't to make that statement false. So I'm going to pick on Sarah real quick. Sorry, Sarah. She said she doesn't have a phone. So if I were to say all of you guys have your phone out right now, I would be wrong because Sarah doesn't. Does that make sense? Sorry, Sarah. Okay, so again, you only have to find how many counterexamples to prove that something's wrong?
1.
Just one. Good. Okay, so that's counterexample. So I'm going to give you an example here. So for these examples, I do want you to put them in your notes, but I don't need you to like write down all the words. So what I want you guys to do is just write these numbers down in your notes. Am I going too fast, by the way? Like, am I giving you guys enough time to write stuff down?
No, I think you're
I
good.
mean, I didn't even get to finish the first slide.
Okay. Well, Alan, I'm gonna, after class, just make sure you
I
look
already
at
see the
the
notes.
YouTube channel, okay? And then you can rewatch the video.
Like I see them on Canvas.
Okay, perfect. All right, so again, you're just writing down these numbers here. And what I want you guys to do, don't like say it out loud or don't say it on the chat yet, but I want you to write down the next 3 numbers that come in this pattern. Okay, so we see this little ellipsis here, meaning that the pattern is going to continue forever. So I want you guys to write down in your notes the next 3 numbers that come after 31. Okay, so now I'm gonna pick some people at random to let me know just the first number that comes after 31. So let's hear from Edith. Edith, what's gonna be just the first number that comes after 31? Say that again.
35.
Okay, 35. Do you guys agree or disagree with Edith's conjecture? Okay, cool. Looks like we're agreeing. So 35's next. Let's go to Janie. What comes after 35? 39. Okay, and what about Laura? What comes after 39?
43.
43. Okay, so what's the pattern that's going on here? Anybody? Okay, good. Everybody's saying you're adding by 4 every time. So what you guys just did, I'm gonna come back to this. Okay, so what you guys just did was you guys used inductive reasoning. You were observing all of these numbers, and then you made a conjecture about the numbers that came after. Okay, so you guys were using inductive reasoning right there. You guys have done stuff like this your whole life. You probably just didn't know it was called inductive reasoning. Okay. And then in the notes, I always give you guys the answers too, so that way, you know, if you can't figure it out, I kind of showed you each time that you're adding by 4 every time. Okay. All right, so there's going to be several homework questions that give you like a little pattern of numbers, and your job is to give you, or to give me like the next 3 or 4 numbers that come in the sequence. Okay. Okay. So the next type of reasoning is called deductive reasoning. And just like how inductive reasoning was called induction, deductive reasoning is also called deduction. So basically, this is just where, again, you're going to come to a conclusion, but it's based off of some statement. So you're not really making observations and making a prediction. You're more kind of almost following a set of rules. And I'm going to show you an example of that right now. Okay, so I'll give you guys a chance to summarize that a little bit before I move on to the next slide here. Okay, so an example is, I'm going to read you guys some instructions, and I want you to write down what I'm telling you to do in your notes. Okay, so I don't want you to write this stuff down, but I want you to first pick a number. So like write down any number that you want in your notes. And I don't want you to tell me what it is. Just write it down in your notes. Okay, so whatever that number was, I want you to multiply your number by 6. Okay, so for me, my favorite number is 2. So I'm going to pick 2, and then in my notes, I'm going to show 2 times 6 is 12. So that's what's written down so far. Okay, then I'm going to add 9 to the product that I just got. So I had 12 was my product. I'm going to add 9 to that, and I'm going to get 21. Okay. Are we okay so far? I don't want to go too quick. If you guys need a calculator, you can get a calculator out too. Okay. Next thing, you are going to divide the sum that you just got by 3. So I'm going to be doing 21 divided by 3 to give me 7. Okay, next, I want you to subtract 3 from the quotient. So my quotient was 7. I'm going to subtract 3 from it, and I got 2. Just kidding. I got 4. Okay. Then make a conjecture, so a prediction, about the relationship between your original number and your final number. So I want to hear from some of you. I want to know what numbers you picked originally and then what final answer that you got. So for me, my numbers were 2 and 4. Someone just like unmute themselves and just tell me your numbers.
9 and 18.
Okay, 9 and 18. Somebody else?
7 and 14.
7 and 14.
I got 6 and 12.
6 and 12.
24, 48.
24, 48. I'm looking at the chat. I heard or saw 12 and 24, 4 and 8. Okay, so I feel like that should be enough things for you guys to make a conjecture about. So what do you think the relationship is between the original number and the final number? Doubled, multiplied by 2. Okay, good. So which number is doubled?
The original number.
The original number. So our conjecture would be that the original number is doubled to get the final number, or you can say the final number is twice as much as the original number. Okay, but you guys can see that it didn't matter which number you picked. It worked every single time. That's why I wanted you guys all to choose your own numbers. Okay. So that would be an example of deductive reasoning. Okay. Okay, that's kind of all I wanted to talk about. There was a proof at the end. This was like the last slide. This is proving why this works for every number. I just kind of want to talk about that for a second. So it says start with a general number. So this is kind of a way to show that any number you pick would work. So just using a variable. So n, and then the second step, the first step to do was multiply by 6. So if you were to do, so there's multiply by 6. So n times 6 would just be 6n. The second step was to add 9. So then you just get 6n plus 9. Then it was divide the sum by 3. So then I would kind of rather write it like this. Whoops. I would rather write it like that. So 6n plus 9 divided by 3. If you were to actually simplify that, you would divide both of these terms by 3. So 6n divided by 3 would come out to be 2n. and then 9 divided by 3 would be 3. So then that takes you here. And then the last step would be to subtract 3. So if I put minus 3 at the end of that, these two would cancel out, and we would just be left with 2n. So the number I started with was n. The number I ended with was 2n. So that shows that this one is double that one. So that's just kind of like the proof. So this allows you to say that this would work for any number in the world. Okay. Okay. So that's all the notes. If you want to take like a little screenshot of this, I'll let you guys do that. But the main things I want to make sure you guys always have is always have the title of the section, always put the date over here, and always put your name on every single page of your notes. Okay. But I'll let you guys, if you want to take a picture of that, so that way you can have that. Again, if you didn't finish your notes, they're still on Canvas. They're always going to be there. So that way you can look back. Do you guys have any questions for me about any of this stuff, like anything you didn't understand? Okay. So what I'm going to do is talk about your homework. Oops, I don't know why I stopped that. Okay. So your homework is going to be, and remember the due dates are always going to be like the time we start class on Wednesday. So like everything's due by 11:54 a.m. every time you guys turn something in this class. Okay, so make sure like you start working on it as soon as we get off of the Zoom meeting, because we're technically still in class, all right? Whoops, I'm on the wrong class, hold on. Okay, so that stuff's done. Again, the notes that I just went over right now are these notes. So that's like the 1.1 notes, the 1.2 notes, the 1.3 notes. I talked about last class, if you want to get more detailed notes, you're going to look at the chapter 1 file. But like the way I made the notes that I just showed you guys was that I got them from this PDF here. Got them straight from the book. See, I talk about inductive reasoning, talk about the natural numbers being counting numbers. We talked about the ellipsis, the little 3 dots. And then there's a little example here. Then we talked about the scientific method. Okay, so there's a lot of extra stuff in here that I don't feel is always necessary, but the first thing that I would want you guys to do if you didn't understand something was to go look at these explanations, because they go a little bit deeper into it. Okay, but the next thing you guys are going to have to do, technically your homework assignments are going to be the discussion for this lesson and the quiz for this lesson. Okay, the discussion, some of you guys already did it. They're going to be the same questions every time. What's one thing you understood? What's one question you still have? Okay, so I would probably do that one right now, because you probably already have questions in your mind from today. Maybe if you didn't understand something, or maybe something really was super easy for you and you got it really fast. So that would be a good thing to write down for number 1. I'm going to pick on Sophia and Alex really quick, because they got it done already. So Sophia said, one thing I understood from the lesson was divisibility. One question I still have was about the counterexample. Okay, so Alex also did his response, but Alex commented on Sophie's original response. So he said, yes, I also understood the divisibility. And then Sophie commented on Alex saying, yes, she understood deduction as well. One thing I would like you guys to try to do is, like, for the question part, how Sophie said that she still had a question about the counterexample, that would be something good to respond to. So like maybe a counterexample was something that you really understood. You could go comment on Sophie's thread, and you could say, oh, a counterexample is this, okay? And then for Alex, when he said one question is what does N stand for? I believe he was talking about that proof that we did at the very end where we started with N. So he said, one question I have is what does N stand for? Does it stand for any number? So you could also respond to Alex and say, yes, N does stand for any number. Okay, so I would kind of like you guys to get into the habit of responding to number 2 when you guys respond to other people's discussions, okay? And then you guys are going to have your practice quiz. I am getting the practice quiz straight off of the practice problems. Okay, I think I told you guys that last class as well. So if you click on this file, it tells you what problems I want you to do for chapter 1. So we would really just need to look at 1.1 right now because that's where we're at. It's on pages 5 to 8, and I want you to do those problems. Okay, in order to find those problems, you got to go back to the chapter 1 PDF, and you got to get through all the notes part of it. So you're just going to scroll down. It says page 5. So right now that's page 2. So I'm looking for page 5. That was page 3, 4. I wonder if you can click up here. Let's see. I want to go to page 10. Oh, that's awesome. All right. So you guys probably already knew this, but like I said, I suck with technology. So if you want to go right to page 5, you can just highlight that and click 5 and then enter, and it'll take you right to page 5. So that's where those practice problems start. So it's going to be pages 5, 6, 7, and 8. Okay, so that's where you'll find those practice problems. Okay, so one more time, your homework is to respond to the discussion and then also respond to one other student. Do the practice quiz, but before you do that, you should probably try out some of those, okay? And then I also want you to just glance at 1.2 before I talk to you guys next, just so that way you kind of have an idea of what we're going to be talking about, okay? So any questions before, how about this? If you don't have any questions, you can just get off, and I will see you guys Wednesday. If you do have questions, you can stay on and ask. And yeah, so if you guys don't have any questions, I will see you Wednesday.
Ms. Wilbur,
Yep.
did you get the email about the campus quiz too? I think? Oh, I can't hear you. I don't see any new ones in the chat. this